Problem 29, we're going to do something slightly more complicated. We're going to do some symbolic arithmetic. Namely, we have an arbitrary complex number. So an arbitrary complex number, or a random one, or a general one, is of the form x plus iy, where x and y are real. So this is just any complex number looks like that. We want to write down an expression that represents the imaginary part of the complex number 2z plus 4z bar minus 4i in terms of the variables x and y. So the first step we're going to do is we're just going to compute. Well, we don't need to even put it in terms of steps. We're going to start off by computing 2z plus 4z bar minus 4i, and then we're going to look at what the imaginary part of that looks like. So let's plug in what we have for z. So z is arbitrary complex number. It looks like x plus iy. So we'll have 2 times x plus iy. And then z bar, bar here means conjugate. So maybe up here in orange, z bar is x minus iy. It's the conjugate expression. So here we're going to put an x minus iy. And then we have negative 4i, of course, has no z's. All right. So let's distribute our 2 and our 4 here. So we get 2x plus, I'm going to put the i's on the right. So 2yi. And then 4x minus 4yi minus 4i. Now let's combine the real and imaginary parts. The real terms are here underlined in green, so that's 6x. And then the imaginary terms are here underlined in orange. So that's 2y minus 4y is negative 2y, but then we also have a negative 4. All right, we've written our complicated expression as a number. Well, it's a variable, but that's okay. Something plus some other expression involving x and y times I. So now we can compute the imaginary part. The imaginary part of 2z plus 4z bar minus 4i is nothing more than negative 2y minus 4. If you give me a random complex number, for example, if z was 1 plus I, which we think of as 1 plus 1i, then the imaginary part of 2z plus 4z bar minus 4i would be here, y is equal to 1. And if you sit there and you plug everything, if you plug 1 plus I in and you check that, you should get negative 6, provided we did our work correctly. So it's a slightly more abstract, complex arithmetic problem where we use variables.